1.
Okay, so we have two equivalent systems looking right at you. So you've got the blue one, system of 3 above. This is going to be known as, in Algebra 2, you would have seen it, as a system of 3 equations, right? In what we're going to do today, to make things a little bit easier to understand those scenarios we just looked at, we're going to look at them in the echelon form. So we've talked about this way back, and we did it on the calculator. We've reduced rows, RREF, reduced rows echelon form. We're actually going to do it now, right? So let's get our terminology right. There's the echelon form of the system. So let's look at the difference between the system of 3 and the echelon form. The system of 3 is all just laid out there, random coefficients to all the variables, so on and so forth. Right? So let's focus on this, right? So you got random, one, coefficient 1, coefficient 3, coefficient 2, all that, right? All 3 variables in all 3 equations. Let's go ahead and look at the echelon form of it. Echelon form allows for a nice, simple back substitution. And these are equivalent statements. They are exactly the same. I converted that first one, I converted this into echelon form. All right, and we're going to do one together in class. But I converted that. Those are exactly the same. But look how much easier this one is, right? You've got X, Y, and Z in the top one with a lead coefficient of 1. That's a key. Then you've got Y and Z in the second one with a coefficient of 1 on your Y. Then you've got Z in your bottom one with a coefficient of 1. So now I can back substitute that into there, and then I'll find out what Y is. And then when I know what Y and Z are, back substitute in there and go from there. But the thing to notice is, well, you will see in the lesson today how it benefits you. So before I move on, I can't say it enough times. My personal preferred method is use a variable, whichever line it might be in. Use the coefficient 1. If you've got a 1x, sometimes you won't, you'll have to manipulate it. But at this level, you're probably going to come up with a 1x, at least to start with today. Use that 1x to eliminate, which you don't know what I'm talking about yet because I haven't showed you, but you will use the 1x to eliminate everything else, versus you wouldn't use like 2x or negative x. Maybe I need to get to the Gaussian elimination, and you'll see what I'm talking about. The 1x, the 1y, and the 1z are crucial here. So let's get on with this. So those are equivalent statements. We can all see that the black one is much easier to look at, much easier on the eyes, we can see it, and you'll see some more appropriate information. When the systems are really easy, it won't make much of a difference. But when we have an interesting scenario. So how do we convert a system of 3 into an echelon form? We use Gaussian elimination, row reduction elimination. Let's just call it Gaussian elimination. It might also be called row reduction. You're not busy. I'm not disturbing you over there, are we? No, you're all right. Okay. Gaussian elimination. So we are going to reduce those rows. We're going to reduce it from 3 systems to 2. So we're going to go from 3 variables, 2 variables, and then 2 variables, 1 variable. Gaussian, we're going to reduce our rows. So let's go ahead and start with this. So I'm going to give you a new equation. So let's go in black. So I want you to start keeping it in order like this. So x plus y minus 3z equal to -1. Then you've got a y minus a z is equal to 0. and a negative x plus 2y equal to 1. So it's deliberate that I left spaces, right? To be able to see the row of the same variable helps you out. I'm going to want to clear this second row and third row are not going to want to have any x's in them. And if there were an x here, once I got rid of that, then I'd have to get rid of the y out of the third row. So I'd only have a z, I'd have a y and a z, and I'd have an x, y, and a z. Now, you get experience, you could move it around, but I highly, highly recommend you put them in order to start with until you get the feel for it. So we're going to do row reduction. This is kind of a simple one, so you'll get to practice a couple. So let's go ahead and make a little note here. So actually, I'll do it the next step. What I'm going to do, I'm going to change color every time I do it. So I'm going to... This is what I want you to do. I want you to bring everything down. So I'm going to use, let me tell you, and then I'll write it out in a minute. I'm going to use row 1 because it has a 1x. That's why I'm using row 1. Doesn't have to be row 1. I'm going to use row 1 to eliminate the x in row 3. In your problem, you might need to use row 1 to eliminate both rows. Depends, but let's see. I've only got it. So now I'm going to use row 1 to eliminate row 3. So that means that row 1 does not change. That means that I'm not doing anything with row 2. So I just do that. Now I'm going to create an equivalent statement by... Now, this is for any of you that code computers. This is like when you put a little tag by your loops or whatever's going on. This is going to be crucial. So right now, this line that I'm going to create here is the new equation generated by adding equation 1 plus equation 3. So now I highly advise you do this for like partial credit because there's a ton of arithmetic errors when you do things like this, right? So if I see what you were trying to do and then you just messed it up, but everything else was right. If you mess up 2 stages, that might just be bad. But you know, if you do that. So let's go ahead and do that. So I just want you to repeat back to me to make sure we're okay. So I'm going to just add row 1 to row 3. So I'm going to add x to negative x. What does that give me? 0. I'm going to add y to 2y, 3y. And then I'm going to add negative 3z to nothing. Okay, and then I'm adding negative 1 to 1. 0. Okay, and some of you can probably already see something, but I want you to follow me all the way through. And even if you do see it, it'll still be true. But I want to show one thing here so that you can see what I'm doing with the multiple. So the black and the green now are equivalent statements. So I'm just pushing it off the screen. So now I need to eliminate the y in the bottom one. So I'm going to use my 1y in my second equation to get rid of the y there. So if I've got 3 y's, in this case, like I say, you can probably already see it, but just humor me because it won't always be this way. If I've got 3 y's right here, how many y's do I need to add to that to make it no y's? Negative 3 y's. So I need to multiply this equation through by negative 3 and then add it to this equation. I'm only worried about the y's. Whatever else happens with the z's and the constants will be. All right? So And after we've done it, I'll go back and point out what I was looking at. All right, so let's do this. So my first equation is going to come along because it's just there and I'm not doing anything with it. My next equation, I'm messing with it, but I'm not actually changing it. Now I'm gonna make a new equation with the bottom one. And this new equation with the bottom, this, whatever I write down here, this new equation is generated by multiplying -3 times equation 2 and then adding it to equation 3. So if you don't know what I mean by the time I'm done writing this, it would be time to ask, okay? So I'm going to do -3 times equation 2. So help me out. -3 times y is -3y. I then add that to my 3y, gets me 0, right? I'm just going to write 0. I'll delete it. I'll erase it in a minute. Then I've got -3z. I'm -3 times -z. Positive 3z. What is positive 3z minus 3z? 0. And then, you know, -3 times 0 is 0. 0 plus 0 is 0. So look what we have. We have 0 minus 0, which is 0. 0 equals 0. So before I talk about this 0 equals 0, you should have noticed right here from your like your vectors, and it's a stretch factor of the same thing. Like you've got y minus z, and you've got 3y minus, well, guess what? I had to multiply this by 3, multiply that by 3, that by 3. They're exactly, these are equivalent statements. They were already equivalent, okay? If you didn't notice it, no big deal, but try if you can, right? Now, let's talk about this 0 equals 0. Let's not just think about it as 0 equals 0. Let's make it in like flower rainbowy, so it's like special, right? It's magical, right? So 0 equals 0. Is that always, oh, that's a bit much. All right, getting a bit crazy. All right, hang on now. All right. Is 0 equals 0? This is what you need to think about. Is it always true? Or is it never true? Always true. Always. Right? So an always true statement would be 7 equals 7. 11 equals 11. You know, a never true would be pi equals e. -2 equals 4. 3 equals 0. Those are false statements. So if at some point along the process you end up with an always true, you've got that situation where you've got infinitely many possibilities, right? From back up here, right? That's what you found. So if you end up with, while I'm up here, if you end up with an always false statement, like 0 equals 7, then you've got a no solution. They don't always meet. None of them meet. None of them meet. All three of them don't meet at the same point. All right, so it's really easy when you're doing this Gaussian elimination, row reduction. If you get an always true, then you know you're going to have an infinitely many solutions, but how do you find it? How do you find out what that is? So I'm going to delete that. So if you wanted to go back and see that in the video, you have to rewind. So there we go. Probably would have been an easier way to do that. So now, basically what this does, 0 equals 0, it doesn't provide us any information at all. So we're just going to rewrite it as if it were x plus y minus 3z is equal to -1, and y minus z is equal to 0. Well, if y minus z is nothing, what must y equal? Y equals z. Y has to equal z, right? So now you've got x plus y minus 3z equals -1, and you've got y is equal to z. So if y is equal to z, that must mean that x plus y, which is z, minus 3z is equal to -1. All right, so let's see, what does that mean? If x plus z minus 3z, so let's just go ahead and give you time to catch up mentally. So if x minus 2z is equal to -1, doesn't that mean that x is equal to 2z minus 1 and y is equal to z? Why?
Because you're subtracting the 2z and you're getting negative way.
You see it?
Yeah, I see it now.
Okay.
Thank you.
You're welcome. So I would make that. I'm glad you keep an eye on me though, because I would make those. So look what we have. We have x and y are dependent on what? Z. X and y are dependent on z. So the solution to the system becomes, okay? So the solution to the system becomes, let's write this. We know what we're doing. Z is going to equal A, and A is an element of the real numbers. So any number, not imaginary, right? So X and Y are going to be defined by Z. Can I mind blocking you? I'm sorry. Good, you can see. So X and Y are defined by Z, but Z, we're not going to call it. Z is going to be its actual, Z is going to have a number based on, so we use this other variable A. You can use anything you want, but define it, right? So what that means is you've got an ordered triple. Z is going to be A. What was Y equal to? Y was equal to Z, and Z is A. So there you go. And then what was X equal to? 2Z minus 1, so 2A minus 1. So now when we use a Z now, we can go back and push it. So let's see if that's true. Let's go and check it, just for the fun of it, and see if it all makes sense. So just to prove I'm not doing anything, pick a really low number so everyone can get 2, right? So let's let A equal 2. All right, so that means the solution is 2, help me out, 2A, which is 4, minus 1 is 3, right? And then A would be 2, 2. So according to us, there is a solution 3, 2, 2. Let's go and check it. Right, do you see it? I heard a what? All right, okay, good. So let's go back and check it in the original. Okay, here's the original. So we said, what did I say? 3, 2, 2, right? All right, so let's check that out. So X is 3. So I don't know what's going on. All right, so I'm doing up here. It's kind of in the wrong way. So 3 plus Y, which is 2, minus 3 times 2 is equal to -1. Is that true? Yeah. 3 plus 2 is 5. 5 minus 6 is equal to -1. Yes. Checks out. Does Y minus Z equal 0? Does 2 minus 2 equal 0? Yeah, and so on and so forth. You pick any other number, it will also work. Pick a fraction, it'll work. Any number. E, pi. What? 1/2. Okay. So let's start 1/2. So it's is 2 times, what was it? 2 times 1/2 minus 1?
Yeah.
Yeah, is that right?
I think so.
I got to go check now.
3 times 1/2 minus 1.
I was trying to think what. 2a minus 1, yes. 2a minus 1. So 2 times 1/2, which is 1, minus 1 is 0. And you said 1/2 and 1/2. So let's check that. So x is 0. So 0 plus 1/2 minus 3/2 should equal negative 1.
It does.
Yes, it does.
That's crazy.
All right. So, all right. So let's check. We're check for understanding right here on what's expected. All right. So you're gonna go through. You are gonna do. I'll put on the board the numbers you're gonna do here in a minute. I want you to do the 3 problems. There's going to be an infinite solution, a no solution, and a 1 solution. I want you to do them. You know, it's the practice of doing it, right? I want you to do it. I want you to keep all 3 lines every time. And each time you're going to use one line to reduce the other rows. All right? And then you're going to add those together. I'm going to want you to be writing this. How did you get this new equation? Oh, I added equation 1 to equation 3. I added equation 1 to equation 3 based on your new one. So the format that I'm defining is your new equation that shows up. So we're your universal system, so I know how to grade you. The new equation will be based on the statement above it. When you say you added 1 to 3, I'm going to go up and look at 1, 3 and see if that's right. And I'll be able to tell, right? So if it would have been right but you made a mistake, that's a good thing, right? And then this new equation we generated here came from doing -3 times equation 2 plus equation 3. So you did that from here and here. And when I say that, I'm like here and here. All right, and then you end up with that, and then you back substitution, and then if it's a form and infinite, write it like that. Okay, your practice problems are on page 506, and they are numbers 15, 21, and 25. Okay, so I'm going to pay you for these. So in class, you don't have to get them all right. You don't have to get them. But what I'm going to do is I'm going to just be watching. If you don't get them all done, but you were working the whole time, it's fine. If you ask me for questions, fine. If you do all that stuff, I just want you working on them and practicing it, and I'll give you participation points. But if you don't get them done, and I've seen you chatting a little bit too much, then we're done. Yes, you just won't get anything. Okay. All right. Off you go. 506. Let's go.